Hello, in this video we're going to be learning about box and whisker plot. So let's say you and your friends went trick-or-treating and come back home and you all decide to count the number of candy pieces that you each got. So all the data is over here and you decide to put all this data into a diagram to be able to see the data a little better, be able to analyze it. So you decide to create a box and whiskers plot, also known as a box plot. So box and whiskers plot. And to be able to construct a box and whiskers plot, we do something called the 5-number summary. So 5-number summary. And there are 5 parts to this. So 1, 2, 3, 4, 5. So 5 parts to constructing a box and whiskers plot. So the first part is, the smallest value. What is the smallest value in your data? So the smallest value in our data is 22 pieces of candy that Isa brought to the table. So 22. Let's skip over 2, 3, and 4 and go to the 5th one. So our fifth part of the 5-number summary is the largest value. So we just finished the smallest value and we're moving on to the largest value. And our largest value is 43 pieces of candy from David. So 43. Now, moving on to our third one, skipping the second one and the fourth. Let's go to the third one. So the third one is the middle value or the median value. So the median is another word for middle. Median value. So when you organize the whole thing in a list in numerical order, so it would be 22 is the smallest number. Then we have 27, then 29, 30, 33 occurs twice, 33, and then 30, then 36, 37, 40, and 45. So we have 10 friends and we can double check the numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So great. We have all of our values. So let me just move this a little down. This as well. Great. Oops. Okay. So to find the middle value, we take the total number of values, so that's 10, and we divide that by 2. So 10 divided by 2 is 5. And we count 5 from both sides. So 1, 2, 3, 4, 5. So this is our 5th value. And then 1, 2, 3, 4, 5. So we have 2 numbers. So there are 4 numbers to the left of this number. And there are 4 values to the right of this number. So both numbers have the 4 values to the left or right of each other. So what we're going to do is find the mean or the average between these 2 numbers. Since they're the same number, the mean is going to be the same. But if you want to double check, that would be 33 plus 33. So that would be 66. And then 66 divided by 2 is 33. So this value, the median, would be 33. Great. So now moving on to our second part of the 5-number summary, which is the lower middle. So lower middle. Okay. So the lower middle represents the lower half. So the half was here. So we have 5 numbers this way and 5 numbers that way. 5 and 5. So you basically cut it in half, so we make sure that there's half and half. And we find, this is the lower, so the lower's on the left side. So, easy way to remember it, lower starts with an L, and the word left starts with the letter L. And we find the median, so middle is another word for median. So we find the median in this lower half. So that would be this number. So we have 2 to the left of this number and 2 to the right of this number. So this would be 29. Our next one is the upper middle. Since we'd finished the lower middle, we'll take the upper middle, or median, upper median. Okay, so now we find the upper middle, so of the right side of the barrier. So that would be 37 because we have 2 on the right side and 2 on the left side of the number. So that would be 37. Okay, so now that we have all the numbers for our 5-number summary, we can start to construct our box and whiskers plot. To do this, we need to start out by laying out our graph. So let's create something that's about this big. Okay, that's good. So let's start by going from 20. Okay, so 25, 30, 35, 40, 45, and 50, 55. That should be good. So our smallest value is 22. In a box and whiskers plot, we do not place points. We draw lines instead. So at the 22 mark, we're going to draw a line. So 22 is around here. So notice that the Y, where you put the Y, so I can put it this high or this high, it wouldn't matter as long as you're putting it in one place. And all of them, so all the other number summaries should be in that same line as well. So going on to our second value, which is 29. So 29 is somewhere around here. So notice that they're in the same vertical line. And then 33 is around here. And then 37. And then 43. So 43. And then to connect our box plot, we take the middle 3 lines, these 3, and we draw a line connecting all 3 of them. So one line here and one line at the bottom. And then to connect these 2 lines at the end, we just draw a line from the middle to the end, middle to the end. Something like that. So this would be your box and whiskers plot for this set of data right here. And these lines are divided into segments. So these lines right here, this is a segment, this is a segment. Each number summary is a segment, and we call our segments quartiles. So these segments are called quartiles. So in box and whiskers plot, we start off with quartile 0. We don't start off with the number 1. We start off with the number 0. This would be Q1, Q2, Q3, and this would be Q4. There are 5 number summaries, so 1, 2, 3, 4, 5. It looks like we have 4 because we are starting with the number 0. So this would be Q0, Q1, Q2, Q3, and Q4. So Q0 is always going to be the smallest value. Q1 is always going to be the lower middle. Q2 the median. Q3 the upper. And Q4 always the largest value. Now, there's a slight twist to having the smallest value or the largest value. So let's say your friend Carl showed up late and he brought 60 pieces of candy, or let's say this time it was 100 pieces of candy. So the data point would be somewhere all the way around here. And, that seems pretty off, right? You can't, all the data is somewhere around here, and then you have one person all the way over here. So this is called an outlier. So right here, so this point, when you have outliers, you generally call them as, you display them as a point on a box and whisker spot. This would be an outlier. And let's say your friend Jenny, or did I use the word Jenny? Nope. So your friend Jenny, started late, she had a club activity or something going on at school, and she got back late, and she had only 7 pieces of candy. So that value would be somewhere around here, and the data, you're stretching the data way too far. So this would also be an outlier. So how do you know if it's definitely an outlier or not? Well, there's this simple formula to find out what is an outlier and what is not. So we're finding out the bounds of what can be an outlier or not. Okay, so the formulas for the lower outlier, so to find out the bound for the lower outlier would be Q1 minus 1.5 times IQR. We'll find out what IQR is in a second. And the upper outlier formula for finding the upper bound is Q3 plus 1.5 times IQR. So the IQR equals the interquartile range. It means the interquartile range. And this equals Q3 minus Q1. So our Q3 value is 37. So IQR equals 37 minus our Q1 value, which is 29. So 37 minus 29 equals 8. So our IQR value is the number 8. So to find our lower bound or lower outlier, so we do Q1. So our Q1 value is 29. So 29 minus 1.5 times the IQR, which is 8, would get us 17. So 17 is our lower bound. So if Jenny had 17 pieces of candy, then she would be part of the data as a line. So it would have been a line at 17. So 17 would be somewhere around here, here. So, and then we would have just drawn a line from here if she had 17 pieces of candy, but she just has 7 pieces of candy, so she would be an outlier. If she had 16, she would still be an outlier because 16 is less than 17. So 17 is included. And then for the upper outlier, you just plug in you just plug it in. So Q3 is 37. So 37 plus 1.5 times the IQR. We use the same IQR because Q3 minus Q1 is 8. So times 8. So 37 plus 1.5 times 8 would give us 49. Equals 49. So nobody goes above 49. So if Carl had 49 pieces of candy, we would just draw a line to the number 45 right here, and we would just erase that and draw it all the way up like this. Like this. But that's not the case. Carl has 100 pieces of candy, so he would be considered an outlier as well.